Hey guys, welcome back to Math Unlocked, and I'm your host, Mrs. Rhodes-Grierson. What are we doing today? Today we're looking at solving equations, which means that if you're here and you're here with solving equations, you'd have watched the previous videos on identifying variables, constants, coefficients. You've also watched the video on how to identify your like and unlike terms. So now that you're here, you are ready to solve those equations with me. Now it's an equation because I have an expression here being equal to something here, which is 7. It's the equality that makes it an equation. Now I have a number plus 2 that's equal to 7, and I want to know what this number is. By inspection, I could look at it and tell you that, well, it's only 5 plus 2 that gives me 7. So I could say that, well, x must be 5. And it's a simple equation, so it's easy to just look at it and identify that that must be the number. But let's also look at it at another approach. What if we look at it this way? I have a number plus 2 that gives me 7. So the number was increased by 2 to give me 7. Therefore, if the number is now 7, and I want to know what was that number before I increased it by 2, it means I'm going to do the opposite of what I did to 7 to find out what would have been the number before. X is this number. X is a number that I added 2 to give me 7. So if I manipulate the statement and say that what was the number before adding 2, means I would need to remove 2 from 7 to give me what that number is. Now what we call this is balancing the equation. We're going to do a balancing method. Here I have an equation that says this side is equal to that side. Now I'm going to remove this 2 from the statement by subtraction because it was previously being added. And why I'm doing that is that I want to know what is the value of x. Now x would remain by itself now in the statement. However, it was an equation that was equal, which means that if I subtract 2 from this side of the equation, this expression, I'd have to subtract 2 from that side as well to maintain that balance or that equality. If you manipulate this side by subtracting 2, you have to manipulate that side by subtracting 2 to maintain equality. What happens now is that I can clearly see that 7 minus 2 is 5. So when I'm solving an equation, I will go with the balancing method when I want to show how I arrived at my solution and not just look at the number to see. I can figure mentally what is that answer. I'm going to show them that mathematically by using my manipulation of how to manipulate the different sides to ensure that I'm balancing, that can give me this solution as well. So what if we look at a different equation that has a little bit more to it? What if I gave you 2 times the value of x plus 4 is equal to 10? So we have 2, and I said 2 times the value of x because 2x means 2 times the value of x. I don't know what x is, but there is a number here. So there's a term, 2x is one term, plus 4. So there are 2 terms here being added. So this number plus this number gives me 6, give me 10. It therefore means that if I look at it, I know that this number must be 6 because 6 plus 4 is equal to 10. And therefore, if 2 times a number is 6, if this number is 6, and it's 2 times a number that gives me 6, 2 times which number gives us 6, we would therefore know that 2 times 3 is what gives us 6, which means that x would have been 3. And that's by inspection. I'm looking at it. I know that that is the value. But how do I show working? By doing the balancing method. I'm going to balance through the balancing method. Now there is a number that is here that when I add 4 to it, it becomes 10. What was the number before I added 4? If I add 4 to it to become 10, it means that I could reduce 10 by 4 to see what the number was. Notice I said reduce it because I added it. So now I'm going to do the opposite of what I did before, and I'm going to subtract that 4 so that I know what is the number before I added that 4. Now if I subtract the 4, it means that 10 will also be reduced by 4. Both sides are being affected in the same way. This 4 is now gone, leaving us with what is 2x. 2x is now equal to 6. Now I'm looking at it and I said it's 2 times this number that gives I can therefore do the opposite of that as well to see what was the number before I multiplied it by 2. Now the opposite of multiplication is division, which means I'm going to divide it by 2 to see what is x. What was x before I multiplied it by 2? Now if I divide this side by 2, it's an equation. The other side must be divided by 2 as well, which means that x itself would have been equal to 3. If you're solving an equation, you want to ensure that you know how to balance. You want to ensure that you know the difference, the opposite operations, so that you can remove terms in order to find that unknown quantity. And in order to state what it's equal to, it must be in this equation, it must be by itself on one side of the equal sign. So until I've gotten the unknown variable by itself on one side, I would have not have solved the equation as yet. So you're going to do one for me. Solve this equation. If I give you 5x minus 1 is equal to 14, what then is the value of x? Post your answers in the comments. Let's do this together.